Imagine trying to wipe out a disease, a really contagious one, but the animals, well, they can carry it silently for their entire lives. Sounds almost impossible, doesn't it? But this exact challenge with a disease in pigs actually had huge economic ripples. And, it pushed science forward in some pretty big ways. Today, we're doing a deep dive into Pseudorabies. You might also hear it called Aujeszky Disease. It's a viral disease, highly contagious, mostly hitting swine. Now, you've given us a fantastic set of sources here, really comprehensive stuff from the nitty-gritty molecular details of the virus to these huge national programs designed to stamp it out. So our mission today, let's unpack all this, pull out the key insights, the real nuggets of information, and give you a solid grasp on how this disease, which seems so tough to beat, was largely overcome. And just as importantly, why we still need to keep an eye on it, why it's still a threat lurking in the background.
It really is an amazing story of, sheer persistence. And you hit on the core issue right away. This virus, Pseudorabies virus, or PRV, it sets up shop for life, a latent infection. That obviously makes getting rid of it incredibly hard. But there's a key piece of the puzzle that made eradication actually feasible, despite how easily it spreads. And that's the fact that pigs, swine, are the only natural reservoir, the only place it lives long-term. That's critical.
Okay, let's dig into that. The sources tell us Pseudorabies is caused by Suid Herpesvirus 1, so SuHV1. It's actually related to the herpes viruses that cause things like cold sores or chickenpox in us humans. And what's really fascinating, what jumps out from the reading, is how its basic biology's nature really dictated everything, both how devastating it was and, kind of ironically, how we eventually figured out how to beat it.
Exactly. It's an enveloped virus, double-stranded DNA, and like you said, it's a herpes virus. The absolute hallmark of these viruses is establishing that lifelong latent infection. In pigs, it typically hides out in the nervous system, like the trigeminal ganglia. These are nerve bundles, a favorite spot for herpes viruses. So a pig can get sick, recover, look perfectly fine, but it's still carrying the virus silently.
Right, a hidden carrier.
And then stressors, things like giving birth, being transported, getting another sickness can wake the virus back up. It starts shedding the virus again, spreading it. But often without any obvious signs, the pig is sick, and that's your nightmare for control, that silent spread.
That makes sense. It just keeps circulating under the radar.
Now, while pigs are the main host, PRV can spill over into other mammals, cattle, sheep, dogs, cats, wildlife. But in those animals, it's almost always fatal. Causes severe neurological problems, often this intense itching, which is where that old name mad itch came from, especially in cattle.
Yeah.
Really awful. But, and this is crucial, these other animals are dead-end hosts. They get sick, they usually die, but they don't spread the virus onwards. They don't keep the cycle going. Only pigs do that.
Okay, so that brings us to something the sources really highlight as a game changer. A watershed moment, they call it. The development of these gene-deleted marker vaccines. How did tinkering with the virus's genes like that become so pivotal for actually getting rid of the disease?
This was the absolute key. This led to the DIVA strategy. That stands for differentiating infected from vaccinated animals. It's quite clever, really. See, the virus has genes, some of which aren't strictly essential for it to just replicate, but they're linked to how nasty it is, its virulence. One of these is the gene for a protein called glycoprotein E, or GE.
Okay, GE.
So scientists figured out how to create vaccines by essentially deleting that GE gene from the vaccine virus. Now, a pig that gets this marker vaccine develops immunity and makes antibodies against all the other parts of the virus, but critically, not against GE because it was never exposed to it.
Right, because it's missing from the vaccine.
Exactly. But a pig that gets infected with the actual wild virus, it makes antibodies to everything, including GE. Then they developed a specific diagnostic test, an ELISA test, that only looks for antibodies against GE.
Ah, I see where this is going.
Yeah. So now you could vaccinate your herds, control the disease, stop the worst of the outbreaks, but you could still test them. If a pig tested positive for GE antibodies, you knew it was truly infected, not just vaccinated, and you could remove it. That test and remove capability, even within vaccinated populations, was what turned eradication from just a hope into a practical plan. It was revolutionary for PRV control.
That is clever. So, okay, we know how we can fight it now, but what does the disease actually do to the pigs? The sources paint a pretty stark picture, and it really seems to depend on how old the pig is.
Oh, absolutely. The age factor is huge with PRV. It's almost like 3 different diseases. For the youngest ones, the newborns, suckling piglets, say under 3 or 4 weeks old, they're incredibly vulnerable. You see almost 100% getting sick, and sadly, almost 100% mortality. It's a devastating, rapid neurological disease. High fever, they stop eating. maybe vomiting, diarrhea, then muscle tremors, shivering, they can't coordinate, they might paddle their legs, have seizures. There's even this characteristic sort of dog-sitting posture they sometimes adopt. And death comes fast, usually within, 24 to 48 hours.
Wow, that's incredibly fast and brutal for the little ones.
It really is. Now, as they get older, say weaned pigs, growers, finishers, their natural resistance kicks in a bit more. The disease shifts. It's much more likely to be a respiratory problem. Fever, off-feed, lethargic, maybe losing weight, sneezing, coughing, runny nose, difficulty breathing, even pneumonia.
So, less neurological.
Much less common, and usually less severe if it does happen. But mortality is still a factor, though variable, maybe only 1–2% in older finishing pigs. But it can jump up to 50% in nursery pigs, especially if it's a particularly nasty strain.
And the big economic hit here is performance. They just don't grow well. Poor feed conversion. It can add, 10 days, maybe 2 weeks to the time it takes to get them to market weight. That costs money.
Right, adds up across a whole herd.
Definitely. And then you have the adults, the breeding sows and boars. Here, the infection can often be quite mild, maybe subclinical, maybe you barely notice it in the individual animal.
Yeah.
But the real damage, the economic catastrophe, is reproductive failure in the sows. You see embryonic death, abortions often mid to late-term stillbirths, mummified fetuses, or they give birth to weak, trembling piglets that often don't survive.
So it hits reproduction hard.
Very hard. And boars might show a temporary drop in libido or semen quality, so it hits the whole breeding cycle. So you've got this triad: catastrophic deaths in piglets, breathing problems in growers, and breeding failures in adults. It sounds like if this hit a farm that had never seen it before, it would be pretty obvious something was wrong. How do vets confirm it's actually PRV beyond just seeing these signs?
Well, those clinical signs, especially that age-dependent pattern, are a very strong clue, particularly in a herd that hasn't encountered PRV before. That gives you a presumptive diagnosis. Looking inside, postmortem findings can sometimes be subtle. You might see tiny dead spots, necrotic foci in the liver or spleen of the really young piglets, or pneumonia in the older ones. Microscopically, though, the key finding, the hallmark, is a specific type of brain inflammation, non-suppurative meningoencephalitis. That's a big clue under the microscope.
Okay, but for definitive proof.
For confirmation, you need the lab. Viral detection is key. Nowadays, PCR is the gold standard. It's fast, super sensitive, very specific. Finds the virus's DNA. You can run it on tissues, swabs, even oral fluids collected from ropes the pigs chew on. It's very versatile.
Faster than the old ways.
Oh, yeah. Virus isolation, actually growing the virus in the lab, that works, but it's slower. Takes, 2 to 7 days. PCR gives you answers much quicker. And then there's antibody detection, looking for the immune response in the blood serology. ELISAs are the workhorse here, especially for checking lots of samples, like in surveillance. And crucially, those special differential or marker ELISAs we talked about, the ones that detect only the GE antibodies, those are absolutely essential for that DIVA strategy for telling infected from vaccinated animals.
Right, connecting back to the eradication tool. Which brings us to the bigger picture. The U.S. National Pseudorabies Eradication Program, often held up as this huge success, right? Kicked off formally in 1989, and by 2004, the commercial pig herds were declared PRV-free. Given everything we've discussed, the latency, the different signs, how on earth did they structure such a massive effort?
It was truly a monumental undertaking, and its success really hinged on cooperation. It was a state, federal, and industry partnership, all coordinated by the USDA's Animal and Plant Health Inspection Service, APHIS. The structure was clever. They set it up in 5 stages, progressive stages. This allowed states to move forward at a pace that made sense for their situation based on hitting specific benchmarks. So stage I was basically getting ready, setting up surveillance and committees. Stage 3, that was the tough part, mandatory cleanup of infected herds, finding them and eliminating the virus. Stage V was the goal, official PRV-free status.
And what made it actually work, beyond just the stages?
Several things were absolutely critical. First, the technology. We keep coming back to it, but those DIVA marker vaccines and the matching diagnostic tests were the technical foundation. They made test and remove feasible even while using vaccines. Second, that public-private partnership was vital. Producers were initially pretty skeptical, but industry groups like the National Pork Producers Council ran pilot projects that showed it could work. That built trust and consensus for the national push.
So getting buy-in was key.
Absolutely. And third, you needed the right economic and policy framework. Clear rules, strong regulations, and significant federal money. Especially things like indemnity payments, paying producers fair market value if their infected herds had to be depopulated. That was boosted in 1999 with the Accelerated PRV Eradication Program. That financial support was crucial for getting compliance. It shared the burden, recognized it as a public good, not just an individual farmer's problem.
Okay, you mentioned the cost, the investment. Eradication on that scale must have been incredibly expensive. What was the justification? How did the economics stack up? The sources mentioned a benefit-cost ratio.
Yeah, it definitely wasn't cheap up front, but you have to compare it to the cost of not eradicating. PRV itself was incredibly costly to producers. We talked about the death losses, like nearly 20% drop in pigs weaned per litter, double or triple the pre-weaning mortality. Add the slower growth, the reproductive failures. It could easily cost a farm over $200 per sow they had.
Huge losses.
Huge. So just trying to control PRV, living with it, meant ongoing costs year after year. Vaccinations, managing outbreaks, lost production, estimated at over $30 million a year nationally back in the late 90s. Eradication, on the other hand, was a big investment, yes, like that $80 million boost in '99, but it was a finite investment aiming for a permanent solution. Economic modeling clearly showed that over a 10-year horizon, eradication was actually the least costly option compared to just continuous control.
So it paid off in the long run.
It did, and the overall economic benefit was significant. The benefit-cost ratio was calculated at 1.89, meaning for every public dollar spent, there was about 189 cents in economic benefit generated. The total economic welfare gain projected was over $370 million. But here's the really interesting part, maybe even surprising.
Go on.
While producers definitely benefited from not having the disease drag down their herds, the modeling showed the biggest financial winners were actually consumers, to the tune of about $336 million.
Consumers, how does that work?
Because getting rid of the disease makes the whole pork industry more efficient. Healthier pigs, better growth, more stable production. It leads to a more reliable, affordable supply of pork in the grocery store. Lower prices for consumers.
Huh. That's a fascinating insight.
It really is. And it provides a powerful argument for why using public funds for eradicating animal diseases makes sense. It benefits everyone, not just the farmers. It's a true public good.
Okay, so the U.S. commercial herds are declared free in 2004. Victory declared, right? Sounds like case closed. But the sources are really clear. Getting to PRV free wasn't the end. It was more like the beginning of a new chapter, a new kind of management. What are these lingering challenges? Why can't we just, relax?
That's exactly right. Achieving freedom was step one. Maintaining it is the ongoing battle. And the biggest, most persistent challenge, without a doubt, is the feral swine population.
The wild pigs.
Yes. They're widespread across the U.S., large numbers, and studies show maybe 20% of them nationally carry antibodies to PRV. They act as this huge, uncontrolled reservoir of the virus out in the environment. This poses a constant risk of the virus spilling back into domestic pigs, especially for farms that have any outdoor access or less than perfect biosecurity. It's a continuous threat at the fence line.
That sounds difficult to manage.
It is. And then there's the other major threat, foreign animal disease introduction. Or perhaps more worrying now, these emerging, more virulent strains of PRV. Since about 2011, particularly in Asia, in China, new strains have popped up. These are highly pathogenic variants. And the scary part is, they can cause severe disease even in pigs that were vaccinated with the traditional vaccines, the ones based on the older strains.
Vaccine breakthrough strains.
Exactly. If one of those strains got into the U.S. pig population, which is now largely naive, it could be catastrophic. Our existing immunity, our vaccine stockpiles might not offer full protection. So the whole game changes. It's less about cleaning up infection within the country and more about defense, like you said, moving from an internal war to more of a Cold War footing, keeping threats out.
So this Cold War, what does that look like in practice? To maintain freedom, what are the key things the sources say we need to be doing? What are the recommendations?
It really comes down to vigilance and preparedness. First, robust national surveillance. We need ongoing, smart, risk-based monitoring, especially watching that interface between domestic pigs and feral swine. And importantly, using modern tools like PCR and genetic sequencing to actually characterize the strains we find in wildlife. Know your enemy, essentially.
Right. Surveillance. What else?
Second, and maybe the most critical thing farms can do, strict biosecurity. This is the #1 defense. It means continuous education for farm workers, being really careful about where new pigs come from, a solid quarantine period, at least 30 days for any new animals, with testing before they enter the main herd, controlling traffic onto the farm vehicles, using things like Danish entry systems where people shower in and change clothes, and solid fencing to keep wild pigs out. Practices like all-in, all-out production flow also really help break disease cycles.
Biosecurity, biosecurity, biosecurity.
It's paramount. Third, we need solid emergency preparedness plans. Detailed plans, updated regularly, practiced. They need to cover everything. How to detect an outbreak fast, how to implement quarantines and stop pig movements quickly, how to ramp up diagnostic testing capacity, and clear strategies for what to do if there is an outbreak, whether that's targeted depopulation with indemnity or maybe emergency vaccination campaigns. And these plans have to be flexible enough to handle either the old classical strains or potentially these new variants.
Preparedness is key.
Absolutely. Fourth, continued investment in R&D. Research and development is crucial. We need to prioritize funding public and industry to check how well our current vaccines work against these new variants. We likely need to develop new vaccines, ideally DVA-compatible ones, that specifically target these emerging strains. And we always need better, faster diagnostic tests.
Keep the science moving forward.
Always. And finally, international collaboration. Animal diseases don't respect borders. So working globally through organizations like the World Organization for Animal Health, being transparent in reporting outbreaks, sharing virus samples and genetic data, agreeing on diagnostic standards, all of that helps create an early warning system for everyone.
So looking back at this whole deep dive on pseudorabies, it's quite a story from this hidden, devastating disease to, well, a real triumph of science, cooperation, and policy working together. But as you made clear, it also really underscores that winning isn't, a final state. It's something you have to keep working at constantly.
It's a perfect example, isn't it? How deeply understanding the enemy, the virus itself, coupled with innovation like the DIVA vaccines, and getting everyone pulling in the same direction, government, industry, researchers, can achieve what seems almost impossible. But it's also a stark reminder that pathogens don't stand still. They evolve, and that means our vigilance can never really end. We always have to be watching.
So maybe the thought to leave you, our listener, with today is this. Thinking about pseudorabies, this specific battle, largely won but still demanding vigilance. How many other threats that we think are dealt with, maybe even eradicated, are quietly out there, still evolving, still changing, perhaps in a wildlife reservoir somewhere just waiting for an opportunity? What might be the next vaccine breakthrough variant that's already emerging, getting ready to challenge the victories we thought were secure? Definitely something to think about. Thank you for joining us on this deep dive.